Hi friends, let's have a look at problem 3211. Generate binary strings without adjacent zeros. So in this video, we're going to explain a solution by constructing all the valid strings. So the problem statement is very short. So here we are given a positive integer m. So a binary string s is valid if all substrings of x of length 2 contains at least one digit 1. So in other words, there are no consecutive zeros in the string x, right? We want to find such strings. So here, let me first comment on this one. This statement is equivalent to say that there is no adjacent zeros in x, right? This is what we mean by valid. So here you have two examples. This n equals 3, you have 5 such strings, and n equals 1, you have 0 and 1, right? So here the positive integer n is bounded above by 18, so which is not very large. So if you consider all the binary strings of length say 18, so the possibilities is like this, right? It's less than 2 to the power 20, right? So in other words, it's sub-million scale, right? So in this way we can construct all valid strings. So here, how do we construct all these strings? Here are some hints, right? So I'm going to use this one. If you have say a length n valid string, then it's very easy to construct length n plus 1, right? For example, you have 0, 1, 0, right? For this one, so if we want to construct valid string, so you can add say 0, 1, 0, but you can not add 0 anymore, you can add 1 only. So that's one case. Another one is that if you have a string of length 3 and the ending at 1, then you want to construct, so you can add say 0 or 1, 1, you can add a 1, or you can add a 0, or you can add a 1, right? Both are okay. So this, in other words, we need to look at the tail or the last digit, and then we can consider append 0 or 1 accordingly to maintain the extended string valid. So this is also the idea we're going to use to solve this problem. So now let's look at the coding. For the coding, actually, we can use recursion. So like recursion, but it's actually just the brute forcely build this. Because here n is greater than or equal to 1, less than or equal to 18. If n equals 1, so we know that we're going to return this one. So we are going to return this one. And so now let's look at the general case. So we are going to start from n equals 1 as a base, right? Let's copy this part. And let's see. Then we are going to, so because we want to get length n, so for get length 2 we need 1 more, for length 3 we need 2 more, and for get length n we need for a number index for range say n minus 1, right? So in this case, let's get new valid strings, right? So we are going to construct new valid strings from the valid strings, right? So this is a very simple. We just use a for loop for string for s in valid strings. Then we are going to check as here the last digit. So if s last character equals 0, so in this case we can only add 1 at the end. So we're going to do valid new valid string So we are going to append s plus the digit 1. So otherwise, so it means the last digit will be 1, right? So here, let's see. So we are given positive, yeah. So here the digit, the valid strings are 0 and 1. So if it's not 0, so it's going to be 1. So then we can append 0 or we can append 1. So we are going to do copy this line. So first add 1, and then we can add also 0, right? Then for each iteration, we're going to reset this valid string state to be this one. Once we finish the for loop, we are going to have all the valid strings of length n. So in this case, we just need to return valid strings, right? So I would say this is one way of doing this problem. And due to the problem size, so basically we do the construction specifically, right? Let's do some test. So this is for n equals 3, we get 1. For n equals 1, it should be right? And we can also check for n equals 18, right? Yeah, it's also accepted. Now let's submit for the generic case. Yeah, it passes all the cases. Actually, as hinted by the problem. So here, if you use hint 3, so you can use recursion and we can use backtracking to generate all such strings. I would say this is a good example to practice recursion and backtracking. So here for this specific solution, hope it provides you some insight. So with that said, I guess that's it for the current video.